The first approximately half hour or so, I'm going to talk as the chairman of the CanSIA's committee we're developing an innovation committee. We're doing a roadmap. I'll talk about that. And the second part of the discussion, I'm going to talk to you as the CEO of Ubiquity Solar and some of my thoughts and experience on innovation. So I'm kind of wearing two hats. So without much more ado, just go here. Okay. I'm going to stand out here because if I get behind the podium, I can't point at stuff. So today's agenda is I'm going to go over the slides. I made a presentation at CanSIA in December. If some of you were at that presentation, I apologize for that, but I'll throw in some extra stuff just to make it interesting for you. And in that presentation, I'm going to talk a little bit about my innovation history, why innovate, and what is Canada's innovation agenda, and what we're doing at CanSIA, and how we're going to promote this to government and various stakeholders. The second part is I'm going to talk about our company's view of the current opportunities and issues in innovating in this space, and what are some of the key success factors that I think, and we're going to end with the kind of top 10 success factors and have hopefully a couple of minutes for some Q&A. Oh, wrong way. Oh, okay, so sorry, confused myself. So this is a presentation I made in CanSIA in September. So a bit about my innovation history. I've been involved with solar since 1996. The very first project I was involved with was this. That was on the '96 Olympics in Atlanta. It was building integrated PV with microinverters. It was funded by a couple of $1 million from the U.S. Department of Energy. And it was a very high-profile project, so I kind of got started with a bit of a bang here. I became chairman of the board of that company and spent a lot of time with Stephen Strong, who is a real pioneer in the field. He did the very first grid-tied solar home in 1979, and he has got. If you have a chance to hear him speak, definitely go up on that. He's very entertaining. One of his famous little lines are, "If it exists, it must be possible." And solar does exist, and what you'll see as a theme is this is happening much faster than anybody thought. So this is some of the stuff we did this was with CanMet. We did Canada's first solar subdivision with the TEAM project about 10 years ago, project with Queens. This is a customer of ours, Solon, in Europe. This was the first 1 megawatt building integrated PV system done in Germany in the late 90s. And that's my home. We've been connected to the grid since April of 2000. And here is a big fit project that we did at Arise. Been very much involved with a lot of R&D at three universities here at McMaster, University of Waterloo, University of Toronto. Been very much very interested in high efficiency solar cells. And I'll explain a little bit more later why I think that's the key thing. We also at Arise developed what I now call our Gen 1 polysilicon process. It went after kind of a 7 to 8 N purity, something in the middle between upgraded metallurgical grade silicon and scrap that the industry had been living off, and a kind of 10 N material that the electronics industry used. That was a good technical success. With the changes in the dynamics in the market, just a bit of foreshadowing, we're going to our second generation polysilicon technology, and I'll explain a little bit more about that towards the end. In 2006, I was approached by the German government to build a cell factory in Germany. They offered to give us 25 million euros. I'm not used to people coming up and offering me 25 million euros, so I took it. And then went around Bay Street and said, the German government's giving us 25 million euros, why don't you give us some money too? And so we raised, we just happened to hit the right wave at the right time. 2007 was the peak year for financing and solar companies, and in a real whirlwind, we raised over $100 million of equity, took the company from being a venture exchange company to graduating to the TSX, and built a cell factory in record time. In fact, I was at a PVSec conference, and there were some guys from China, and they were saying, oh, you guys in Europe, it take a couple of years to build a cell factory. We can build our cell factory in just over a year. And I said, well, we built ours in 8 months. And that kind of ended that conversation. So there, and one of the key things when we took a look at this was I was concerned about the low-cost labor in China. And our labor cost was, at that time, 5% of our cost of goods. And we could sell our product in Germany for a 5 to 10% premium. So even if in Asia they had free labor, we still had a competitive business. What I didn't think about, and what many people in the industry didn't think about, is incredibly low cost of capital in Asia. And that's the big difference. And that's why pretty much all cell production has gone to Asia. And I think as this industry sorts itself out, similar to what the semiconductor industry did in the 90s with all the semiconductor wars, then Canada will sort out where it fits into that ecosystem, and that's part of the things that we're trying to do with the CanSIA white paper and roadmap. So that's a bunch of stuff that we did. And that was a great opportunity, great learning experience, and you learn from your mistakes. So why innovate? You know, that's a pretty basic question. Why are we innovating? So if you're going to be innovating, let me tell you, you're getting on the solar coaster. So just be prepared for that. And it's a compelling industry, but hold on to your hat. And the way I would summarize the industry today is to quote Dickens, it's the best of times, the worst of times, the age of wisdom, the age of foolishness. And you have to know what you're getting involved with. So in the best of times, the industry continues to grow. It's cost effective. There's so much opportunity that's going on. Yesterday, the EPIA came out with their annual 5-year projections. One of my favorite reports. Go to the EPI website, epia.org. Take a look at their market projections. Interestingly enough, for the second year in a row, PV was the #1 new form of electrical generation in Europe. And it was greater than wind and natural gas combined. So solar is no longer a niche player. Solar is a mainstream energy technology in Europe. In 2012, 2.6% of all of Europe's electricity came from solar, 5.2% of the peak demand. Germany is getting 11% of its peak energy from solar, and on one day it hit 45% of all electricity being consumed in Germany was from solar. So this is real, this is happening now. Worst of times, well, the company I started blew up, but the analogy I've used over the last year and a half, 2 years, if your house falls down on a sunny day, you look kind of stupid. If your house falls down after the worst hurricane of the century and half the houses on the street are blown away, you get a lot of sympathy. And so, but we've seen this consolidation before, whether it's PCs, radio in the 1920s, the automotive. There's a couple hundred car companies in Detroit in the 1920s. So we've seen this before, and what happens when an industry comes out of nowhere and it's going to be an absolutely huge industry, a lot of smart people figure that one out, and they all jump in. And you go through this cycle, massive amounts of capital coming in, people building factories, and then combined with all of the other aspects of climate change and job creation and stuff like that, we're going through this consolidation. In terms of wisdom, we are starting to see that PV has a profound ability to change this planet. Absolutely profound. It's a very wise technology. And it's a lot smarter than burning fossil fuels. The foolishness is we got trade wars and stupid technology and inappropriate management and blah, blah, blah. So that's how I would sum up the industry. So just to give you a sense of what's been going on, this is just the big picture on a log curve, because I think there's a bunch of technical people here, so I get to pull out the log curves. This is how PV is growing. Notice how the grid tied market basically has taken over, and this was as of last year, this ended up pretty accurate. So we did 31.4 gigawatts of installed PV. I think off-grid will continue to play a growing important role now that solar is so cost-effective. So this is a graph that I did, and I took the basic concept from Joachim Luther, who at the time was the head of the Fraunhofer Institute in Germany. He gave a guest lecture at the University of Waterloo in the late 90s. And I went looking for that graph. He actually gave me the graph. And what's interesting is, so back then, if you took a look at this trajectory, what his graph said, somewhere around 2075 will power the planet. And I thought, well, that's interesting. And I kind of remembered, and then last year I said, I got to put the data on a graph and see what happened. And I was absolutely shocked. Really, like, I'm a solar guy, I know this stuff. And I was shocked, because look what's happening. This is the total amount of energy we use on the planet. I'm not talking just electricity, I'm talking planes, trains, automobiles, and cheap movies. And if you keep on going the way you're going, somewhere in the 20 to 30 years from now, we're powering the entire planet. It's over. We've obsoleted fossil fuels, nuclear, and everything. And all of you guys most of you are younger than me, unfortunately, but you're going to see this before you retire. You'll be sitting there and telling your grandkids, yeah, I remember when we talked about obsoleting fossil fuels. And Grandpa, what's a fossil fuel? They're like, so that's the data, and it's been accelerating. Like, this is the biggest big picture on energy you're going to get, and it's happening now. There's a whole bunch of issues, and that's why little dotted lines, and that's somewhere where this is going to go. But so we don't really know. But I can tell you one thing: it is happening faster than people thought. So, for example, I was at the Photon conference in Munich in 2005. Mike Rogel got up, who is one of the best analysts in the industry, said, in 2000 we're going to do 6 gigawatts. And Winfried Hoffman, who is the president of EPIA, got up and got into a public argument saying, how could you say that? The analysts are saying, between 3.3 and 3.9 gigawatts. If you go around saying people are not going to lose all our credibility, and you can't say that. And I went up to Mike later. I said, well, I actually think your data is right, Mike. He said, yeah, I know, Ian. I don't understand why all the controversy is. I just think it's going to be probably around 6 gigawatts. It was 16.7. That's what happened. And so this is happening faster than anybody thinks. So experience curves. So my first real job was working for Hewlett Packard as a field engineer, which is a fancy name for a salesman. And I sold oscilloscopes and power supplies, network analyzers, all the stuff that eventually became Agilent. And I'm down on a corporate training course, and then one of the guys says, oh, this next talk I heard about it, it's absolutely the best one. It's by Chuck House, the director of engineering. And he talked about experience curves. And he talked about how computers in the year 2000 were going to cost $1 a MIP. And we were blown away because computers cost $1 million a MIP in 1981. So to go from $1 million to $1 in 20 years seemed pretty far-fetched. So if you go forward to the year 2000, bought a computer with a Pentium 3 running at 600 megahertz, the one that you have in your closet somewhere, that sold for $2,000, and it was 2,054 MIPS. So I'm a very strong believer in experience curves. So in 97, when I came across experience curves in PV, I started following it pretty closely. And started watching it, and I was so pleased. I started plotting with my little graph, and every year I go find the data and plot it on. And in 2003, we were the Canadian distributor for Sharp, and we were buying modules for $3 a watt. And I said, by the end of this year, we'll be able to buy them for $2.86. And at the end of the year, I was able to buy them for $2.85. And I thought, gee, aren't I brilliant? Unfortunately, there's a giant sucking sound in Germany, and the market couldn't keep up, and so ultimate prices went up to $4.50, and we almost went out of business because of that. Now, the thing to remember is experience curves, it's very easy to measure price. It's very difficult to measure cost. And the difference between that line and that line is extraordinary profits. And so what happened is all of a sudden these companies were making huge amounts of money, and the financial markets noticed that, and they poured a whole bunch of money into the whole thing, which resulted in that. Now, I kind of forgot about experience curves for a couple of years, and I wasn't putting my data into it. So around this time right here, I was putting the data into my graph, and I went, uh-oh. If this thing snaps back to the experience curve, we're done. And a lot of companies in the industry are going to be done like dinner. And fortunately, I didn't pay attention to myself, and I forgot about that. And this time, I'm going to be watching experience curves very, very carefully, because I don't want to make that mistake again. So what happened is now, interestingly enough, the price is now snapped below the curve, and no one's making any money. Big surprise. So now the result is, let's watch this and kind of continue down here. Now, this data right here is that point right there. So the question is, notice where that price is, 12 cents a watt. That's where we're going. We're going to go to 12 cents a watt. I don't know exactly when or how, but I wouldn't be surprised that somebody in this room, or maybe even several of you, have an influence and an impact on getting to 12 cents a watt. And that's what we're trying to do with the roadmap. So this is happening, again, faster than people thought. So what we're trying to do right now with the solar industry in Canada is a bit of a one-trick pony with the feed-in tariff. And from a government standpoint, what we're trying to do is influence the government at CanSIA to have a broader innovation agenda. Because I think Canada does have a role to play in this global international market. We have to figure out where we play. I think the vertical integration, do all things to all people, is probably going to fall away. But I think there's some specific areas where Canada can make a contribution. So we got this advisory council. We're focusing on electricity, PV solar electricity versus PV. And that the reason for that is now that solar has gone mainstream, what people care about is electricity. They like to get their electricity from maybe a distributed source, and there's a bunch of benefits with PV, but we're focusing on electricity. And in December, we produced a white paper. If you want more information on this, go to the CanSIA website. I think they tied it to a December 2nd press release. You can download it from there. It's 28 pages, and it was a good start. And what we've also said is in December of 2013 at CanSIA, we're going to release our technology roadmap. So it's a bit of a labor of love for a number of dedicated people. And we also want to take a look at this. It's not just a technology part, but innovation in financing, innovation in installation, innovation in delivering more cost-effective solar electricity. These are the folks that are on there. We have a good mix of academic and government, industry people from different parts of the whole thing, and so it's a broad brush approach. We, of course, If somebody here is interested in being involved with this in some fashion, let us know. There's more work to be done. And we're just starting to ramp up the roadmap phase. So that's, and then at CanSIA, I gave this talk, and then we had a Q&A panel, and those are the people that participated. We even got into a bit of a debate about DC versus AC and whether Tesla and Edison was right, or who was right, but anyhow. So that is what we're doing from CanSIA's standpoint. So the next couple of slides are some of my thoughts. Not that I wasn't giving any of my thoughts earlier, but before I get into the technology side of things, I wanted to have one slide on policy. I don't know how many times people have come up to you, but I get this all the time. Oh, solar's not cost effective. There's so many government subsidies. Okay. So yes, the IEA the International Energy Agency has said there's $88 billion of subsidies to all renewable energies, including wind and solar and stuff like that. The International Money, International Money Fund, IMF, some rinky-dink government agency or something with very little credibility. But anyways, but seriously, $1.9 trillion, that's the subsidies to fossil fuels. And so we need to, if people, next time somebody says, okay, we got to, renewable energy is subsidized, well, let's get rid of all the subsidies and level the playing field. So enough on that, but it's one of the more interesting slides I've come across lately. So one of the major conclusions that I have come to is it's about above average cell efficiency. And when I first started working on PV development, it was at the University of Toronto in 2001. We had a low-cost roll-to-roll amorphous silicon technology that looked pretty interesting, and that's where we're going to go. We had a strategic partnership with a company called Colmeg. At that time, they were the largest manufacturer of disk drive platters. We got to know them, and we ran it through their manufacturing cost model, and to my great shock, it was not cost effective. And these guys put down more thin film than the entire PV industry. Now, they're all on little disk drive platters, but it was thin film. Fortunately, Nazir Karani, I don't know if he's here today, he and myself had talked about a second generation product called a heterojunction device, where you put amorphous silicon on silicon. We ran the same thing through the cost model, and the margins were eye-popping. They're really, really good. So we changed that and started taking a look at heterojunction devices. So a key theme here is above average cell efficiency leverages the entire value chain. And that if you have just a little bit more efficiency, you're putting less modules on, you can get more modules on the roof, and the market has responded with different pricing. So when you are working on developing a solar technology, take a look at what the levelized cost of electricity is for your technology, but a general rule is you need to be above the average efficiency. If you are below the average efficiency, and even with low cost, all that does is it improves your profit margin, and in fact, you pay a penalty. And so people will pay less for your product. So just latest on pricing. The key point of this slide here is this is the Ontario market, which is a bit of an artificial market, so pricing is much higher. This is where the world market is. So just if you're looking at module prices here locally, it's an artificial price. This is a slide that I did earlier this year, and I'm not saying that the data is super precise. I took it out of Photon magazine and made some educated guesses. But what's interesting is in 2008, you saw a definite price slope for higher efficiency. And over time, efficiency's been improving on average, about 0.25% per year. It's been doing that since 1954. Because when Chapman, Fuller, and Pearson came out with their first silicon-based solar cell, it was around 6%. That was an N-type back contact solar cell. It looks an awful lot like SunPower. And today they're at 21%, so 60 years times a quarter percent per year, that's where you come up with. And that trend has been pretty consistent. Some years a little bit better, some years a little bit worse, but that's a good long-term trend. So if you take a look at, in 2008, this is the prices, and you go back to, if you had a 0% efficient solar cell, you have to sell it for $0, but anything above that you could make money on. If you now take a look at 2012, at 8% cell efficiency, you have to sell it for free. It doesn't, no one wants to buy it. And I did a small consulting gig as an expert witness for a failed amorphous silicon company last year. And so I had a chance to look under the hood, and I basically said, well, I don't think you'll ever make any money doing this. And so so this is real market data. You see the shifts in efficiency and the compression of pricing. It's amazing how prices have come down so much. So if you have a really low cost, low efficiency solar cell, really think about how you're going to get the efficiency up, and think about the manufacturing context. Part of the reason for this is, if you go back here, you take a look at where module prices of say 75 cents, and then you go forward here to system prices. System prices have not come down as fast. A rule of thumb a couple of years ago is you took your module price, doubled the price, and that's your system price. Now you have to triple or 4 or 5 times your systems price. And because you have all of this cost on the systems level, it's a much greater overhead. So I would argue that efficiency is even more important now than it used to be, because the modules are so low cost. So and you see where on the utility scale market, where First Solar, for example, has been a major player, where they've had a less efficient system, their systems costs are lower. So it makes sense. You can get away with lower efficiency. Where you take a look at SunPower, they've been selling just a beautiful product but at a premium, and they were going after the residential market, and that's because system costs are higher. So it's really, really important that you take a look at how efficiency and cost fit together. But as a general rule of thumb, go for high efficiency and low cost. That's the benefit. So the other thing to take a look at is, and this is a really good report, Google Berkeley Labs, and find this Germany versus US. There's a big difference between Germany and the United States, and Canada is pretty similar in this range here. So what's interesting is the real high efficiency people like Sanyo and SunPower, recently talking with various colleagues in Europe, they seem to have given up on Europe, and they're putting a lot of their marketing effort on the residential market in the US, because that's where the economics are the best for their premium high efficiency product. And so as your systems and balance of systems comes down, efficiency becomes less important. So it's that ratio, the greater the ratio between your module price and your systems price, the more important high efficiency is. Now, this is a very busy slide, but what I've tried to do is, on one slide, put all of the technologies that I know about. And they're basically thin film, you got silicon, and you got the advanced technology. And I ranked them in terms of efficiency and examples of the various technology. And what you see is all these people up here are shut down or struggling or having problems. All those people down here are having cost issues and struggling, and this is where the growth is. So this is what has happened over the last 20 years. Interestingly enough, all of this technology has been around for more than 25 years. The only real new thing that I've seen is the whole quantum nano implication, which has an implication for all of these technologies. And I think that's going to be a very, very interesting area. And not too sure how it fits out, and there's going to be a lot of stuff thrown out the wall. We'll see what sticks. But I think that has a profound impact on all of this technology. I actually think it has the most impact in here. And so this is a slide that I had did for a proposal back in 2007. And basically what it shows is there's a sweet spot here where your cell costs are going down, and then you start getting into exotic cell structures and your cell starts to go up. And so there's a point in here that's the sweet spot. And that's the point of the graph. And if you take a look at the earlier graph, we've seen this played out here. And for example, the heterojunction, that's been having some cost issues. Roth and Rau's been busy trying to sell their turnkey lines. Last time I heard, they haven't sold any yet because there's cost issues with these exotic cell structures. SunPower, fortunately, has got Total behind them, and they have a systems perspective, but they're not making any money making they're beautiful. I just love their modules. I think they're technically so elegant, but they're just expensive. So you got to understand the implications of this chart. So this is in February 2013. This is at the cell level. So this is your homojunction commodity solar cell. This is the product that we would make at Arise in Germany. And what we're seeing is that this is the cell efficiency. And this is typically, this area here is the sweet spot. This is where probably 95% of the production here. If you can get up into this area, you can make a real premium, and that's how you make money in this business. And I'm talking, we would sweat over 0.2% cell efficiency and just go through everything to get there. And if you're below that, you're done. This is stuff you sell at a discount. You're not making any money here at all. So you really have to be pushing this as far as you can. And this is the market condition. So this is what the pricing is. And the market decides on what's important. So here's another graph basically showing that thin film peaked not too long after the big silicon shortage, and it's been going downhill ever since. So I would be very cautious on a thin film story unless it's something that's special and has high efficiency, but really go through your costs. One of the most interesting things that have happened recently is First Solar, the company that totally aced it on thin film, in April bought TetraSun, a bunch of ex-SunPower people that have a high efficiency, low cost technology. And so much lower cost than your standard HITS cell, but so similar pricing to your commodity, but higher efficiency. This is the sweet spot. That's where, if you have something like this, then you got something. There's not too many transactions that are happening right now, but this happened recently. And interesting enough this is from, I copied this out of their investor at their AGM. They had a slide. And this is how they summed up their strategy: TetraSun, low cost and high efficiency. And First Solar probably has the highest market cap in the industry. I can't point to a company that's done a better job at executing on a business plan. They've really aced it and have a huge amount of respect. They have moved. They now are bracketing the commodity product out there, which is another smart business strategy. So here is recently the top 10 for 2012. What you notice is all of them are in Asia. Now you have companies like SunPower, which is an American-based company, but most of their production capability is in Asia. What you also notice is everybody's holding. There's not a lot of expansion right now because there's excess capacity in the industry. So I know from a lot of the talks and a lot of the research people are doing here that it is, you were doing a lot of stuff on cell production or cell tech, research into cells. And so if you want to use the definition from the other day, if you want to innovate, i.e. invent and then commercialize, you need to understand what is driving the market and what some of the economics are. So success factors, these are my top 10. Understand what is the future, underlying future, price performance economics. I can't emphasize enough how important it is to understand where the economics are going. And to really understand how you make money in this business. I keep on going back to its high efficiency, low cost. And what are the real trends? What are the real manufacturing costs? This right here, the ITR PV from SEME, that's an excellent resource if you want to get a sense for where crystalline technology is going and in terms of efficiency and trends and manufacturing stuff. The second thing is have a clear understanding of what your contribution is. Is it just a Me Too thing, or is there a real unique customer benefit, a contribution with this technology? There's a lot of technology out there. There's fewer companies. How do you get it from the lab into commercialization? And also, does your technology fit into the context of a broader product? So do you have some services that do, or you're able to leverage some unique business model that will be important? So understand your contribution. Have a strong team with industry experience. With what we're doing with Ubiquity, we have a very strong team. I can't emphasize enough how important it is to have industry experience. I look for that a lot more than I used to. Back in 2006, when Arise really took off, I didn't have a lot of industry people I could bring in. And I think some of the mistakes we made at Arise was because I didn't have strong enough industry experience. Great managers, very smart people, and a great team, but I'm putting a much greater emphasis on industry experience. The industry is going through this restructuring consolidation phase, and it's going to end up around large companies. I think it's going to be pretty challenging to start a company in your garage and take it where it needs to go. But then again, I got a bunch of stuff in my garage right now, so what can I say? But it's about large companies, and so how do you fit your technology into large companies? And so how do you add value to them? So it's not just your path from the lab to the customers, but it's probably going to go through some kind of company. And the challenge you have is how do you leap the not invented here barrier when they have a lot of R&D going on? So that's something that I would give some thought to. So in terms of public and private markets, the capital markets have been burned badly, both venture capital and the public markets. So I do think, like anything, they will come back in the next couple of years, but really focus on capital efficiency and raise the least amount that you need. The other big hurdle you have is economies of scale typically drive cost reduction. And we learned this firsthand at Arise. We had to grow, we couldn't grow, couldn't get the capital because capital was very expensive in Europe, very cheap in China. And so what the Chinese did, and the Asian companies in general, is built really large factories, got the economies of scale. So they got costs down through more through economies of scale than technology. And so if you're going to get costs down through technology, how do you deal with those economies of scale issues? Because you may have compelling technology that is 25 cents a watt at 1 gigawatt, but if at 10 megawatts it's $2 a watt, how do you get there? And so those economies of scale plays an important thing. And if you can develop some technology that has a modularity, so at 10 megawatts, your cost structure is very similar to what it is at a gigawatt. That's a very compelling third dimension for you to take a look at. So it's high efficiency, low cost, and modularity, so you do not have the huge economies of scale that the conventional technology has. So those are the three things. Back. How does your system fit into, how do you fit into an existing process? So if you have to design a whole new process and spend $100 million on a cell line because it's a brand new process, that's a bit of a challenge. If you can say, well, we're going to tweak, we're going to add one step to the process and get 1% higher cell efficiency, you're going to get a lot of people's attention. So if it fits into an existing process, that's good. How does it fit into the systems context? Again, think about, it's about the levelized cost of electricity. How does this impact everything here? And does your technology simplify or add complexity? You take a look at BIPV tracking microinverters. All of those add some simplicity. They also add complexity. So think that through, because obviously simplicity is good. Complexity adds costs. And a lot of times people forget about this level of complexity. And I think the other theme that's evolving here is it's broadening. Because now that PV is a mainstream technology, it has to fit into this broader context. So I think storage is now a huge issue. It's certainly, Germany just announced their incentive program for storage. 5 years ago, storage, who cared? You're producing 1% of the electricity in the grid, whatever. The grid will take whatever you want. You're producing 10%, 20%, storage starts to become an issue. So so how you fit into that in the broader transmission smart meters, electric cars. Just as a little data point, today, if you bought a bunch of solar panels and plugged it into your electric car and displaced retail gasoline, you have a 7-year payback on gasoline in Canada today. In Germany, it's 2 years. So solar is cost effective against fossil fuels. Now, we'd all love to be driving Teslas, but so as that electric car thing starts to kick in, that's going to really throw on the afterburners for this industry. I think also the health, safety, environmental is becoming more important. And somehow I got 11 now. Oh, somehow 6, missing 6. I solved that once, I just took it off. Anyways, and the other thing is this whole macroeconomic, political, environmental, security, scarcity, jobs thing. That broader political environment is very important. So let me just take a minute or two and just share a little bit of what we're doing and how this fits into this criteria. So I didn't make this up as just a general, bunch of good ideas. This is the process that I've gone through in architecting a business. So I have a really good understanding of the economics, where it's going, and took a look at the economics out over the next 10 to 20 years. And what we're doing is we're working on high efficiency wafers, or wafers with a very high minority carrier lifetime. It's an integrated polysilicon ingot process that will deliver float zone-like performance at CZ level pricing. And we think it's a compelling thing because it fits nicely into this high efficiency, low cost. Our cost structure is similar to the industry, but we think we can drop these wafers into an existing process and improve cell efficiency by 1 to 2%. So put a lot of things. So I understand our contribution. I had some initial discussions with a tier 1 PV company, and the general manager, the first thing he said to me after I explained all this is, gee, that's really interesting, and can we have an exclusive? Well, I very politely said no, but people want to improve their profit. The very best, one of the lessons I learned at Hewlett-Packard is how HP would sell a lot of really expensive computers and test equipment that was typically much more expensive than our competition. Is we understood the business, and we understood how our product would make a contribution to that company to improve their profit. So when you're talking, if you have a chance to talk to a CEO, talk with him about how you can improve their profit. Don't talk with him about technology. So understand your contribution. Strong team. I've aced that. I'm so excited about the team that we've put together. I've built a lot of relationships over the years. I basically called up all my friends and said, hey, this is what we're doing. You got this compelling idea. And pretty much every one of them said, hey, I'm in. And I have 10 PhDs involved with what we're doing, people with deep experience in the electronics industry that we're going to apply to the PV industry. So recognizing that I maybe could have done a better job on this, maybe I could, maybe I couldn't, but the people weren't there at the time. I learned my lesson, and we're really focusing on industry experience. So that's really important. Industries restructuring, so we understand that. We're targeting 21 companies worldwide that will buy our product. We know who they are, we know their names, we know where they live. That's a good place to start your marketing strategy. So if you know 21 customers, that's on your target, you probably have a good understanding of your market. More importantly, is there's maybe about 100 theoretically worldwide. I also know why I'm not talking to the other 79. And that's an important factor too. So, private and public markets, I have to be a bit careful because of securities laws, but if you had told me a year ago that I would consider taking a company public, I would have said, why don't you take me out back and shoot me now? Here's the gun, there's the head, just pull the trigger, please. I've kind of warmed up to the whole public thing. When you have a public company that you started actually go bankrupt, it's kind of embarrassing in the Globe and Mail and calls from reporters and stuff like that. But so going public is one of the exit strategies that we're looking at. But most realistically is that we will probably get acquired by one of those major companies. Because if we deliver on what we have, what we think we can, then it is a true game changer. And not only will people want it, everybody, they want to keep it to themselves. Large companies tend to have that greedy thing happening. They like to keep everything they don't share well. I don't know. Big companies, they just don't share. I don't know. Back. Economies of scale. This was a real sleeper issue. One of the guys that is involved with what I'm doing, he was responsible for building a polysilicon plant that cost $2 billion. And it was a very complicated plant. And he took a look at what we're doing, and he said, Ian, you don't know what you got here, do you? I go, well, yeah, I got high efficiency and low cost. Isn't that great? So, no, you have modularity. Do you realize what it takes to turn on $1 billion polysilicon plant? We can start small and just grow a step at a time. This is absolutely huge. This is the game changer. And if you take a look at business history, there's a steel company called Nucor. It's a very interesting business case study. A lot of business cases written on it over the years. They revolutionized the steel industry because their focus was on modularity. And so pay special attention to this thing because that's, I think, a big hot button. So how do you fit into the existing process? With respect to what we're doing, I was responsible for purchasing 25 million wafers. I know what they look like. We spent $130 million at Arise on wafers. The biggest thing that I fussed with over 3 years in Germany is wafer suppliers. Drove me nuts. I know what the good ones are. I know what the bad ones are. So we're going to compete with them, and some of the bad ones I'm going to put out of business. That's my revenge. Put those bad suppliers out of business. You're dumb suppliers. You're out of business. Go away. That's what I want to do. Anyhow. But it fits in. Now, what we can do is we can take this product, drop it into a cell line, walk to the end of the line, and 3 hours later go, oh, it works. They don't have to change their process. And so if you can have some technology that you can drop into an existing cell process or something else with respect to PV, if it's in that process, that's a very compelling thing because you don't have the big jump. You don't have to, well, gee, I need $100 million to build a cell line. So how does it fit in the systems context? I think high efficiency, we're a step removed from all of this, but this fits into the whole high efficiency part of the thing. Health, safety, I think this is going to be a growing importance. One of the guys that's working with me, he spent six months in China. dealing with the Tier 1 Chinese polysilicon supplier that is presently shut down. He told me on the weekend, if they turn that thing back on, it will blow up and people will die. So think about the health and safety aspects of what you're doing. Back a number of years ago, when I was looking at various polysilicon technologies, I got really excited about a tribromylsilane process. And a friend of mine who was a chemical engineer from McMaster, a bunch of smart people here, I told him I was all excited about this, and he knew me well enough, he could tell I was excited about it. He said, Ian, we're going to get together for coffee because I got to talk with you about this, but I don't want to do it over the phone. Oh. So he showed up and sat down. He said, now, Ian, he looked at me straight in the eye. You don't want another Bhopal. Tribromylsilane is explosive and poisonous. Don't do it. Fortunately, I listened to him, and I didn't do it. So our process, what we're doing, is probably the safest way to do polysilicon, and certainly one of the safest. So take a look at, don't forget about this health and safety thing. And this whole macro side of things, we're certainly paying a lot more attention to this. We have some interesting dinner time conversations with my wife. For those that don't know, she ran in the last two federal elections for the Green Party, and so we have a kind of a poll. My wife Kathy is keeping me abreast of all of these things, and she also happens to be on the shadow cabinet for the Green Party as the natural resource critic. She wants Joe Oliver's job, so that's just kind of the full, true, and plain disclosure thing. So you get a sense of where I'm coming from. So, anyways, those are my key success factors and how I'm applying it to the design of our business. So, Q&A. How much time do we have?